Hello and welcome to this Edexcel Further Statistics 1 video looking at the mean and variance for the negative binomial distribution. You may like to pause for a moment here and just familiarise yourself again with the probability function for the negative binomial and also for the definitions of the two parameters involved. The population mean for a negative binomial is defined as R divided by P, and you may recall the mean for the geometric is 1 divided by P, and you could think of the mean of the negative binomial as R multiplied by the mean of the geometric. The variance for the negative binomial distribution is defined as R 1 minus P over P squared. And if you recall, the variance for the geometric distribution was 1 minus P over P squared. And again, we have a factor of R involved. And you may like to think why the negative binomial mean and variance might be R multiplied by those of the geometric distribution. It's something you could perhaps think about and research. The definition for the probability function, the mean and the variance for the negative binomial are all given in the formula book. If we now look at an example, and I'd suggest you pause for a moment here and just read through this example so that you can identify the model involved. In the final paragraph of this example, we are asked to investigate the number of requests before all three servers fail. So we are interested in a third server failing, which identifies the parameter R as 3. The probability of a success, that in this case is actually a server failing, is clearly given to us in the example, and X, the random variable, would represent the number of requests necessary until the third server fails. So we have here all the information on this slide, and what we now need to do is find the mean for X, the mean number of requests necessary, which is simply R divided by P, which in this case equals 6,000. And looking at the summary of all the information we've found so far, we have found the mean is 6,000. So on average we would expect to have 6,000 server requests before all three fail. And just note at the bottom there, I have just evaluated the variance for you as well. This second example is quite different, and again I suggest you pause for a moment and just read through the example so you can have a think for yourself about what information we're being given. So the final paragraph of this example asks us to find the probability of winning P for any one game, and the target number of games to win R, because Ahmed's going to keep playing until he's won the game on R occasions. and the information we are given are the values for the mean and the variance. So in some ways this example is the other way round to the previous example we looked at. If we then turn the information in the example into mathematical statements, we are told that the mean is 40, so r divided by p must equal 40, and the variance is 120, so r multiplied by 1 minus p over p squared is 120. And this is going to provide us with simultaneous equations to solve. The first one is very simple, and the second one slightly more complicated, but both just connecting r and p. And I think it's fairly clear that we would substitute the information in equation 1 into equation 2, and that will then give us this equation here to solve a fairly straightforward quadratic equation to solve for p. So this slide summarizes all the information we have gathered so far and brings us to the point on the previous slide where we found the quadratic equation. If we multiply out the left hand side and tidy up the terms, because p has to be positive, it's very easy to find p equals 0.25, and we know from the first equation that r is 40 multiplied by p, therefore r equals 10. And this means that the probability that Ahmed wins a game on any one occasion is 0.25, and he will keep playing the game any number of times until he has won on 10 occasions. And that's the end of this video. The next video will look at the derivation of the mean of the negative binomial distribution.